Welcome to this video lecture on the subject Optical and Microwave Engineering. So in this lecture we are going to discuss about Gunn Diode Oscillators. So Gunn Diode is basically a microwave semiconductor device. So some microwave devices include point contact diode, varactor diode, Gunn diodes and impact trapad diodes and etc. So these diodes are useful in microwave frequencies where conventional diodes cannot function because of the significant inductance and high capacitance and high transit time. So these are the reason conventional diodes cannot be used at microwave frequencies. So we use microwave semiconductor devices. So one of the devices is Gunn diode. So it is used to generate the microwave signal. So around 1 gigahertz and up to 100 gigahertz range. So these diodes are normally known as transferred electron devices, where it consists of an N-type semiconductor only. So it does not possess a PN junction. So, and Gunn diode is normally used for generating the microwave signal. It may be also used as an amplifier. And it consists of two electrodes and it is fabricated from the single piece of N-type semiconductor. So some common materials are gallium arsenide and indium phosphide for the fabrication of Gunn diodes. So it consists of an N-type bar with N plus contacts. So N-type material is used for transferred electron effect, where it is only applicable to electrons and not holes. So this is the construction of a Gunn diode. So this diode is negative differential resistance device, which is frequently used as a low power oscillator. It consists of active layer, which is N type, and also it consists of N plus contact. So to generate the short radio waves such as microwaves, it utilizes the Gunn effect. Next we shall see the characteristics of Gunn diode. So for example, consider a current voltage characteristics. So it exhibits a negative resistance characteristics. So the Gunn diode operation depends on the fact it has a voltage controlled negative resistance. So this device exhibits a negative resistance region on its VI curve. The negative resistance enables the Gunn diode to amplify the signal and enabling it to used in amplifiers and also oscillators. So as the field increases, the electron drift velocity in gallium arsenide reaches a peak and then decreases. So this electric field increases, the energy of the electron also increases. So the electron can be scattered into upper valley as shown in this diagram, where the density of effective mass is 0.55 m0. So it is discovered by J.B. Gunn, which is known as Gunn effect, and he observed random noise-like oscillations when it is biased in N-type gallium arsenide sample above a certain threshold value. He also found that resistance of the samples dropped at even higher biasing conditions, indicating a region of negative differential resistance. So this diagram shows the sustained oscillations produced in the Gunn sample. So materials which have the Gunn effect such as gallium arsenide, indium phosphide and gallium nitride must be direct bandgap materials. It means have more than one valley in the conduction band and the effective mass and the density of the states in the upper valley must be higher than the mean valley. So it is important to note that the sample had to be biased in the NDR region to produce a Gunn domain. So this Gunn domain is formed, the electric field in the rest of the sample falls below the negative differential resistance region, and therefore it inhibits the formation of the second Gunn domain. So as soon as the domain is absorbed by the anode region, the average electric field rises and the domain forms again. So this creates the AC current oscillations. So we can use the Gunn diode as a Gunn diode oscillator, where the Gunn diode will be placed in a resonant cavity. It consists of two major components. One is DC bias and a tuning circuit. So this can be used for generating the sustained oscillation till the TC bias is present. And this is the tuning circuit. So the oscillation frequency primarily depends on the middle active layer of the Gunn diode. However, the resonant frequency can be tuned externally by mechanical or electrical means. So for electronic tuning circuit, the control can be brought by using a waveguide or microwave cavity or varactor diode. And these are the applications of Gunn diodes. It is used as a low power oscillator at microwave frequencies and used in radar transmitters and pulsed Gunn oscillators in transponders for air traffic control, low and medium power oscillator microwave receivers. Let's take the assessment. Gallium arsenide is used in the fabrication of Gunn diodes because it has less forbidden energy gap. When the electric field applied to gallium arsenide specimen is less than the threshold electric field, the current in the material increases linearly. Thank you for listening this lecture.